Good morning, students. In the previous class, that is the class 1 of the chapter, group 16 element or oxygen family, I completed the introduction part. That is, what is about the members of this family, electronic configuration, general trends in physical property, general trends in chemical property, and anomalous behavior of oxygen. Today, that is in class 2 of this chapter, group 16 element, I will try to complete the method of preparation of dioxygen, property, uses of dioxygen, then method of preparation, property, uses of ozone and oxide, different type of oxide. So let us start the first one, that is a method of preparation of dioxygen. Mark that. First one is methods of preparation of dioxygen, means O2. There are 2 to 3 methods are there. First we discuss, that is by the decomposition of oxygen rich compound. The first method is by the decomposition of oxygen rich compound. Mark that. So many oxygen rich compounds are there. For example, potassium permanganate, potassium chlorate, potassium nitrate. Mark that. The oxygen rich compounds are there. KMnO4, potassium permanganate, KNO3, potassium permanganate, potassium nitrate, potassium chlorate, KClO3. These are the oxygen rich compound on strongly heating give rise to oxygen. That means when potassium permanganate heated give rise to oxygen, potassium chlorate on strong heating give rise to oxygen, potassium nitrate on heating give rise to oxygen. Mark the equation, that is KMnO4 on heating to form potassium manganate. When potassium permanganate on strong heating it form potassium manganate, for manganese dioxide and oxygen. That is K2MnO4 plus MnO2 plus O2. In the first. Another one is by heating potassium chlorate. On heating potassium chlorate give rise to potassium chloride plus oxygen. That is potassium chlorate on heating give rise to potassium chloride, give rise to potassium chloride. When potassium chlorate on heating give rise to potassium chloride plus oxygen. Similarly, when potassium nitrate on heating give rise to potassium nitrite plus oxygen. Third one is potassium nitrate on heating give rise to potassium nitrite plus oxygen. It is the first method, that is by the decomposition of oxygen rich compound. Move to the second method, that is by the thermal decomposition of oxides of heavy metal. That is the second method. Second method is by the thermal decomposition of oxides of heavy metal. By the thermal decomposition of oxides of heavy metals. That means the oxides of heavy metals like mercury, lead, silver, when undergoes thermal decomposition resulting to give rise to the oxygen. For example, the oxides of mercury, that is mercuric oxide on heating. For example, mercuric oxide on heating give rise to mercury plus oxygen. Similarly, on heating, oxides of lead, that is a red lead, when a red lead on heating give rise to lead oxide, that is Pb3O4 on heating give rise to PbO plus O2. Next, oxides of silver, that is silver oxide when heating give rise to silver plus oxygen, that is Ag2O on heating give rise to silver plus oxygen. It is the second method, that is by the thermal decomposition of oxides of heavy metal. Next, move right to third one, that is a laboratory method. Third one is the laboratory method of preparation. Laboratory method of preparation. The dioxin also prepared in the laboratory by the action of water with sodium peroxide. I repeat again. Dioxin also prepared in the laboratory by the action of water with sodium peroxide. That means when sodium peroxide reacts with water, liberating oxygen in addition to sodium hydroxide. The equation is sodium peroxide when combines with water, resulting the formation of sodium hydroxide along with liberating oxygen. So these are the method of preparation of dioxygen. Next, switch over to the properties of dioxygen. Let us, so many properties is there. Let us discuss one by one. That is properties of dioxygen. Next we discuss properties of dioxygen. Point 1, action with litmus. First property, action with litmus. Dioxygen is neutral to litmus. Mark that. It is neutral to litmus. Point 2, that is supporter of combustion. Supporter of combustion. Dioxin is never combustible. However, it is a supporter of combustion. I repeat again. Dioxin never combustible but support on combustion. Next, oxidizing nature. Third one is oxidizing nature. Dioxygen acts as a strong oxidizing agent. Dioxygen acts as a strong oxidizing agent. It oxidizes metals, non-metals and different compounds. Let us discuss one by one. Point 1 is oxidation with metals. Dioxygen oxidizes so many metals to their corresponding metal oxide. For example, sodium oxidizes to sodium oxide, calcium oxide, magnesium oxide. Mark some equation. That is sodium plus oxygen give rise to sodium oxide. Magnesium plus oxygen give rise to magnesium oxide. Calcium plus oxygen give rise to calcium oxide. Aluminium plus oxygen give rise to aluminium oxide. These are some reactions which indicates that dioxane acts as an oxidizing agent. It oxidizes metal to corresponding metal oxide. Next, switch over to that is oxidation with non-metal. Next point is oxidation with non-metal. Dioxygen also oxidizes some non-metal to their corresponding oxide. For example, carbon converted to carbon dioxide, sulfur converted to sulfur dioxide. Mark that. Carbon combines with oxygen to form carbon dioxide. Sulfur combines oxygen to form sulfur dioxide. Phosphorus combines with oxygen to form phosphorus pentoxide. Nitrogen combines with oxygen to form nitric oxide. So many equations are there which indicates that dioxane acts as an oxidizing agent. So B1 action with metal, B2 action with non-metal, B3 action with some compounds. Move to third point. That is oxidation with some compounds. Third one, oxidation with some compounds. Dioxygen also oxidizes some compound under suitable condition to form some useful products. I repeat again. Dioxygen also oxidizes some compounds under suitable condition to form useful product. Let us discuss one or two examples. This is bit one known as contact process. This is a contact process, that is manufacture of sulfuric acid by the contact process. The equation is SO2 plus O2 give rise to SO3. Sulfur dioxide is oxidized to sulfur trioxide. In present suitable condition is 720 Kelvin. That is 2 atmospheric pressure in presence of vanadium pentoxide. Another one is Ostual process. Ostual process, that is a manufacture of nitric acid by Ostual process. The equation is NH3 plus O2 give rise to NO plus H2O. The suitable condition is temperature 1073 Kelvin and catalyst is platinum. Third one, another example, that is Decom's process. Decom's process, that is a manufacture of chlorine by Decom process. Mark the equation. HCl plus O2 give rise to Cl2 plus H2O. That is temperature is 700 Kelvin, catalyst is cupric chloride. These are some suitable examples that oxidation with some compounds. Some compounds oxidize under suitable condition to form different usual product. For example, contact process, manufacture of sulfuric acid, Ostual process, manufacture of nitric acid, Decom's process for manufacture of chlorine. It is the some chemical properties of dioxide. Next, switch over to the uses. So many uses are there. Among the one or two are very important uses. oxyacetylene torch. First uses is oxyacetylene torch. It is important one uses of dioxin. It is used for welding of the metal. Oxyacetylene torch. Next one is dioxin is used for artificial respiration by the patient in the surgery in hospital. And also oxygen dioxide is used for respiration by the sea diver when it is in the deep sea. The sea diver or scuba diver uses a mixture of helium and dioxygen in order to overcome the painful sensation known as a bend. Oxygen also used for different conditions. That is, oxygen also used for in the extraction of metal steel. These are some uses of dioxygen. Next, so you go to another one, that is oxide. Next heading is oxides. What do you mean by oxides? Metals and non-metals. It's a binary compound in which metal and non-metal combine with dioxin to form different type of oxide. I repeat again. Metals and non-metal when combine with dioxin form different type of oxides. In each oxides, the oxygen exhibit an oxidation state of a -2. The nature of a bonding here may be ionic or covalent. There are different type of oxide. Normally, oxides classified into two categories. Mark that. Oxides classified into two categories. One is known as simple oxide. One is known as mixed oxide. Mark that. This simple oxide again categorized into different type, that is acidic oxide, basic oxide, amphoteric oxide, neutral oxide. Mark that. I repeat again. That binary compounds of metal and non-metal known as oxides is generally of two types. One is simple oxide, one is mixed oxide. The simple oxide is one type of classification depending upon acidic and basic nature. And this simple oxide again classified into four subgroups. One is acidic oxide, one is basic oxide, one is amphoteric oxide, and one is neutral oxide. The oxides, that is, the oxides of the metal, the oxides of the compound, when dissolved in water, if resulting the solution is acidic, then that oxide is known as acidic oxide. Similarly, when the oxide dissolved in water, resulting the formation of a base known as basic oxide. The oxide, when combined with acid as well as base, then it is known as amphoteric oxide. The oxide which do not react with neither acid nor base known as neutral oxide. And that one, mixed oxide, combination of two simple oxide in which the metal atom exhibit two different oxidation states known as mixed oxide. Let us discuss one by one. That is, first one is acidic oxide. First one is acidic oxides. What is acidic oxide? I repeat again. The oxides which dissolve in water, resulting in the formation of a solution whose nature is acidic, generally it is known as acidic oxide. Normally, non-metal oxides behave as acidic oxide. For example, CO2 plus H2O give rise to H2CO3. SO2 plus H2O give rise to H2SO3. P4O10 plus H2O give rise to S3PO4. N2O5 plus H2O give rise to H3PO4. Give rise to HNO3. Mark that. It is known as carbonic acid. It is known as sulfurous acid. It is known as phosphoric acid. It is known as nitric acid. All are acidic nature. So generally, non-metal oxides on hydrolysis give rise to product that is known as acidic nature. Then that type of oxide is known as acidic oxide. So you go to next one, that is a basic oxide. Point 2. Basic oxide. Similarly, the oxides when dissolved in water result in the formation of a base. That type of oxide is known as basic oxide. Generally, metal oxides are basic oxide. Metal oxide when dissolved in water result in the formation of base. For example, sodium oxide plus water give rise to sodium hydroxide. Magnesium oxide plus water give rise to magnesium hydroxide. Aluminium oxide plus water give rise to aluminium hydroxide. So mark that these are now well known bases are there. So generally metal oxides behave as that is basic oxide. So acidic oxide, basic oxide, then switch over to third one, amphoteric oxide. Third one, amphoteric oxide. What is amphoteric oxide? The oxide which react with both acid and bases are known as amphoteric oxide. Suitable examples: Al2O3, barium oxide, zinc oxide, lead oxide, etc. These are known as amphoteric oxide. Reacts with both acid as well as a base. Then switch over to neutral oxide. Next one is neutral oxide. The oxides, what is neutral oxide? The oxide neither reacts with combined with acid nor a base, known as neutral oxide. For example, H2O, NO, N2O, etc. These are known as neutral oxide. All these above comes under simple oxide. Then switch over to mixed oxide. Next, mixed oxide. What is a mixed oxide? That means the oxide in which is made up of by combination of two simple oxide, in which the metal atom exhibit two oxidation state, that is known as mixed oxide. For example, Pb3O4, Fe3O4, etc. Here it is one PbO2, PbO, Here is Fe2O3, FeO. Mark that here ferrous ferric. Here is two oxidation state. Here also Pb2O3 and PbO. Mark that two different type of oxidation state of metal atom. So this is known as mixed oxide. It is all about little idea about the types of oxide. Next we go to another compound, that is a method of preparation of ozone. Ozone is prepared in the upper part of the atmosphere. Ozone is prepared in the upper part of the atmosphere when dioxygen came in contact with UV radiation. Mark that. Dioxygen, UV radiation. In the upper part of the atmosphere, when dioxygen came in contact with UV radiation, oxygen transport to ozone. Let us discuss the method of preparation of ozone in the laboratory. In laboratory, ozone also prepared by passing silent electric discharge through the dioxygen. The instrument in which ozone is prepared known as ozonizer. Generally, there are two types of ozonizer is there. One is known as a Simon ozonizer. One is known as a Brody ozonizer. Mark that. In the laboratory, lab method. O2, silent electric discharge. O3. Mark that. The instrument through which ozone is prepared known as ozonizer. Two types of ozonizer is there. One is Simon ozonizer. Second is Brody ozonizer. We discuss the first one, that is Simon ozonizer. In this process, the formation of ozone is about to 10% and rest is oxygen. That's why instead of saying ozone is prepared, it is better to say ozonide oxygen is prepared. Let us discuss what is the type of instrument that is the Simon ozonizer and how the different steps is there and what are the conditions with precaution we have to taken for production of maximum yield of ozone. Mark that. First we discuss that is a Simon ozonizer. Very, very important. It is a long question. Simon's ozonizer. Mark that. Is a two coaxial glass tube. Here pure and dry oxygen. Here ozonide oxygen. Two coaxial glass tube fused together, where inner side of the inner tube and outer side of the outer tube coated with tin foil. This is known as tin foil. And the inner side and outer side, the inner side and the outer side is connected to the two terminal of induction coil. Induction coil in order to form high voltage Mark that. I repeat again. It is a coaxial glass tube. Two coaxial glass tube fused together, where inner side of the inner tube and outer side of the outer tube, that is coated with tin foil. One end is there, opening is there, that is in which inlet of pure and dry oxygen. Here only one outlet is there, that is ozonide oxygen. I repeat again, since 10% ozone is formed, that's why in order to say ozone is formed, better to say ozonide oxygen is formed. We have to take some precaution in order to get a maximum yield. 2 to 3 points are there. There is precaution for maximum yield. That is point 1. Low temperature, that is 273 Kelvin, should be maintained. Point 2. Pure and dry oxygen should be used. Next, the ozonizer should be kept dry. And another point is there. That is the product. That is the passage of silent electric discharge. I repeat again. 4 points are there for condition of getting a maximum yield of ozone. One is known as low temperature, that is 0 degrees centigrade, should be maintained. Pure and dry oxygen should be used. The ozonizer should be kept dry, and the silent electrical discharge, silent electric spark should be used. These are the conditions for getting maximum yield of ozone. Next, we go to the chemical property of ozone. Chemical properties of ozone. Ozone behaves as an oxidizing agent, a reducing agent, bleaching agent. I repeat again. Ozone behaves as an oxidizing agent, as well as a reducing agent, as well as a bleaching agent. Let us discuss one by one. First one is oxidizing agent. First one, oxidizing agent. We know the ozone break down to this nascent oxygen play an important role for behaving the oxidizing agent. So many examples are there. Let us discuss one by one. Big one. It oxidizes mercury to mercurous oxide. Bit one. First example. It oxidizes mercury to mercurous oxide. It oxidizes mercury to mercurous oxide. Reaction mercury give rise to. That means when mercury oxidized to mercurous oxide, it loses its meniscus and stick to the walls of the container. I repeat again. When mercury oxidized to mercurous oxide, it loses its meniscus and stick to the walls of the container. This phenomenon is known as the telling of mercury. It is known as telling of mercury. Mark that. It is known as the upper meniscus. If mercury is there in capillary tube, it is known as upper meniscus. But When it is mercury oxidized to mercurous oxide, now the meniscus loses its meniscus and stick to the walls of the container. This nature is known as tailing of mercury. It is an important question. What do you mean by tailing of mercury? Answer: when mercury oxidizes to mercurous oxide, it loses its meniscus. This phenomenon is known as tailing of mercury. Move to second example. Second example, it oxidizes lead sulfide to lead sulfate. Mark that. Lead sulfide give rise to lead sulfate. It oxidizes lead sulfide to lead sulfate. Next example, it oxidizes moist iodine to iodic acid. Mark that. Next example, third example, it oxidizes moist iodine to iodic acid. I2 plus H2O plus O3 give rise to HiO3 plus O2. It is known as iodic acid. Next example, it oxidizes potassium iodide solution to potassium hydroxide. Next example, it oxidizes potassium iodide to potassium hydroxide. It is Ki H2O plus O3 give rise to KOH plus O2 plus I2. Next, it oxidizes acidified ferrous sulfate solution to ferric sulfate solution. Mark the example. Next example, it oxidizes acidified ferrous sulfate to ferric sulfate. Mark the equation. Ferrous sulfate FeSO4 plus H2SO4 plus O3 give rise to Fe2SO4 whole thrice plus H2O plus O2. Ferrous sulfate transferred to ferric sulfate. Next example, it oxidizes potassium ferrocyanide to potassium ferricyanide. Mark that. It oxidizes potassium ferrocyanide to potassium ferricyanide. Mark that. K4FeCN6 plus H2O plus O3 give rise to K3FeCN6 potassium ferrocyanide transfer to KOH plus O2. Potassium ferrocyanide transfer to potassium ferricyanide. It oxidizes potassium manganate to potassium permanganate. Mark that. repeat again. Next one is it oxidizes, seventh. It oxidizes potassium manganate to potassium permanganate, that is K2MnO4 plus H2O plus O3 give rise to KMnO4 plus KOH plus O2. Potassium manganate transfer to potassium permanganate. Next, it oxidizes acidified stannous chloride to stannic chloride. Mark that. Next example. It oxidizes acidified stannous chloride to stannic chloride, that is SnCl2 plus HCl plus O3 give rise to SnCl4 plus O2. Mark that. It is a stannous chloride. It is known as stannous chloride converted to stannic chloride. SnCl2 plus O2 plus H2O. These are some examples of oxidizing nature. Next, we discuss the reducing nature of ozone. Next we will discuss second one is reducing nature. Ozone also behaves as an reducing agent. It reduces hydrogen peroxide, barium peroxide. Mark that some examples. Hydrogen peroxide plus ozone give rise to H2O plus O2. Barium peroxide plus ozone give rise to barium oxide plus O2. These are suitable examples under the reducing nature. Next, discuss about the bleaching nature of ozone. Third one is bleaching nature, bleaching action. Ozone also behaves as a bleaching agent and it is due to its oxidizing nature. And the bleaching action of ozone is permanent. One more question. The bleaching action of ozone is due to its point one oxidizing nature, reducing nature, bleaching nature, none of these. Answer is the bleaching action of ozone is due to its oxidizing nature and it is permanent. For example, it bleaches the vegetable coloring matter to form a vegetable colorless matter. Mark that. That is O3 give rise to O2 plus nascent O. Vegetable coloring matter plus nascent O give rise to vegetable colorless matter. This bleaching action due to its oxidizing nature and it is permanent. These are some chemical properties of ozone. Last, switch over to the uses of ozone. So many uses are there. Most important use in organic chemistry, it is used to detect the position of the multiple bond. I repeat again. It is used to detect the position of the multiple bond in organic reaction. That is known as ozonolysis. Next, last we discuss about the uses of ozone. uses. It is used to detect the position of multiple bond in organic compound. Next, it is used as germicide and disinfectant. Next, it is also used in improving atmosphere in crowded places. These are some uses. The most important, I repeat again, it is also used as a bleaching agent. It is also used as a bleaching agent. These are some uses of ozone.